All right, so learning objective 23 is to draw Lewis structures for ionic and covalent. So 23b is to draw Lewis structures for covalent compounds. Covalent compounds, or molecular compounds, same thing, share electrons and form covalent bonds. So co meaning same, valent meaning electrons. So they share the same electrons. So steps for drawing molecules or covalent compounds. The first thing that you want to do is write a skeletal structure. And then this is going to give the relative position of atoms in the structure. You need to pick a central atom. So the central atom is going to have the smallest subscript in the formula and has the most single electrons, meaning that it has the most number of bonds it can form. Hint for this, carbon is always going to be the central atom for any carbon compound because it can form up to 4 bonds. And that is probably one of the only elements that can form 4 bonds. Second thing that you're going to do is to calculate the total number of valence electrons of the atoms in the Lewis structure. This is the sum of all the valence electrons in the structure. You need to take into account the charge of the molecule. So is the charge 0, then you don't have to do anything. But if the charge is a positive charge, you're going to subtract electrons. And if it is a negative charge, you are going to add electrons. We're going to look at an example of this in just a second. So a couple of things that can kind of help you here as well is to know your Lewis structures for everything, or your Lewis dot diagrams, right? So carbon's Lewis structure has 4 dots that are around it. This can form 4 bonds. In fact, carbon always forms 4 bonds. So if you do not have 4 bonds to carbon, something's wrong with your structure. Oxygen, Lewis structure, has 2 lone pairs and 2 single electrons, which can form 2 bonds. Nitrogen has 3 single electrons, so it can form 3 bonds. And any halogen, so chlorine, bromine, iodine, or fluorine, can form 1 bond. Usually, unless it's the central atom. So sometimes, as in the case of polyatomic ions, chlorine and bromine and iodine, those are the 3 that can do this. Fluorine is only 1. So chlorine, bromine, and iodine can be your central atom, and they can have more electrons, more things that are bonded to them. This is due to the expanded octet for d orbitals. So hydrogen can form 1 bond, carbon can form 4 bonds, oxygen 2 bonds, nitrogen 3 bonds. That's like your big thing that you can do with this, okay? Might help you open up a problem for you, that type of thing. So you want to distribute the electrons among the atoms. And the way that you do this is by trying to give all atoms an octet. So 8 electrons, unless it doesn't want an octet. So hydrogen does not want an octet. It wants 2 electrons. That's it. Does not want an octet. So again, exceptions to this would be boron, which would want 6 total electrons. Hydrogen, which wants 2. So boron equals 3 bonds, 6 electrons. And hydrogen equals 1 bond, forms 2 electrons. So what you're going to do is begin by placing lines. And I like doing lines between the atoms just because of the fact that would be considered a bond. between pairs of atoms. So start by doing one line. Now, one line is equal to 2 electrons. Then you're going to start dotting everything else. So you're going to circle into the molecule with single electrons. And you're going to start with the terminal or the outer atom, and then rotate inwards until you fill out the total number of electrons that you need. If any atom lacks an octet, you can form double or triple bonds as necessary. So putting another line in or 2 more lines in will help you to do that. So let's look at an example. So we've got carbon dioxide. We know that carbon dioxide, or you should know that carbon dioxide is CO2. What this means is like when we are looking at this, carbon is my central atom, and the oxygens are going to be my terminal atoms. That means that 2 oxygen are bound to 1 carbon. Okay. So then I'm going to write my skeletal structure, and I'm just going to do O, C, O. Then I'm going to calculate my total number of valence electrons. Well, carbon has 4 valence electrons, and oxygen has 6 valence electrons. Well, because I have 2 oxygen, I have to multiply this by 2. So this is equal to 12 plus 4, which is equal to 16 total electrons that I need to put into the structure. So carbon dioxide does not have a charge, so I don't have to worry about adding the charge to that. So I'm going to distribute the electrons. Now, something that might help you see O and O is by drawing the Lewis structures for these, because that might actually help you to determine the structure. So I rotate around 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Now, sometimes this works and then sometimes it doesn't work. So you just kind of have to be careful with it. 1, 2, 3, 4, 5, 6. So if I'm looking at the Lewis structures here, I can see that carbon can bind 4 times and that oxygen can bind 2 times total. So I start by making a line between these 2 right here. So I start by making a line, and then I can make a line between these 2. So I have these 2 lines that I have drawn in. So I've circled these 2 atoms. Now, what I see here is that carbon now has 1, 2, 3, 4, 5, 6 total electrons. Oxygen has 1, 2, 3, 4, 5, 6, 7 electrons each. That's a problem because of the fact that oxygen does not have 8 total electrons around him, and carbon also does not have 8 total electrons around her. So the way we fix this is we make a double bond between the oxygen and the carbon here and here. So then my structure then becomes O with 2 lone pairs of electrons. O should always have 2 lone pairs of electrons, a double bond to carbon, and a double bond to another oxygen. Now, if I look at this, each line represents 2 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. I have 8 total electrons around carbon. I have 1, 2, 3, 4, 5, 6, 7, 8 total electrons around each of the oxygen atoms. And now I don't have any problems there. If I just put one line in between each one, I would not have an octet. Let's look at another example here. I've got the carbonate ion. So I have CO3, 2 minus. So again, carbon is going to be my central atom. Oxygens are going to be my terminal atoms. So skeletal structure, C's in the center. I have oxygen, oxygen, and oxygen around the carbon. So total number of electrons. I have 4 valence electrons for carbon plus 3 times 6 valence electrons for oxygen. But I also have a charge here. So this charge here is added electrons. So I'm going to add 2 electrons here. So I have 4 plus 18 plus 2. So I have 24 total electrons. So then I can start by doing my thing, right? So I've got C, I have an O, I have an O, and I have an O. Now, this means that I have 1, 2, 3, 4, 5, 6 total electrons around carbon. So I still have quite a few electrons left over. I have 18 total electrons that I need to put in. So then I can rotate in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and now I have 17, 18. Now I have all of my electrons in there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Problem with my structure. Carbon does not have 8 valence electrons. It has 6. So this is violating the octet rule. So the way that we fix this is we take 2 of the electrons from one of the oxygens and make it a double bond. So then we have C double bonded to O, to O, to O. And this particular molecule can resonate between structures to stabilize itself. Now, either one of these structures would be correct because it resonates between all of these structures. The electrons move around, they don't stay in one area. That is learning objective 23B, to draw Lewis structures for covalent compounds.